Good morning, everyone. Welcome to this new webinar organized by Edu4Standards. My name is Maria Giuffrida. I will be the person who will introduce this webinar. And so while we wait for other people to join us, I just want to quickly share a few slides with the introductory, let's say, information about this event. So let me put it in full screen. So you should see it properly now. So welcome again, and I'm happy to introduce this actually new series of webinars, which are focused on the green and digital transition, also called the twin transition. We are organizing these webinars in the context of Edu4Standards, as I was saying. Edu4Standards is a CSA, a coordination and support action funded by the European Commission. The project has started in January 2024. It's a 3 year project, so we are towards the end of this initiative. We will officially close the project at the end of this year. In general, Edu4Standards has the main objective to bring together the education component with standardization, so basically to improve the number of higher education offerings in terms of teaching in standardization, and increase also the number of teachers and students involved in standardization. We do so providing methodological inputs, materials, methodological inputs such as an innovative teaching concept of standardization, which has been produced in the beginning of the project, which is being tested in various pilots of different types by the consortium. And we also, let's say, contribute to this mission via a series of communication, dissemination, and engagement activities, such as academic standard days. We are setting up a students association, and of course, we organize online events such as the webinar that we are having today. And among all the materials and modules that we have produced in these 2 years and a half already, we have decided to contribute to this, hot topic, which is digital and green. And we've decided to do so by organizing a series of webinars, but also modules that have different, let's say, formats. Just to give you an overview of how this series is structured so far, we are starting today with the module 1, which is a webinar entitled "The Standards as Enablers of Digital and Green Transitions, a Multi-Level Perspective." This will be delivered by my colleague Nizar from Politecnico di Milano in a moment. Then we have other 4 modules already scheduled or already published on our website. Next one will be in May. It will be focused on privacy, data protection, and standards, engineering European values, organized by Polytechnic University of Madrid. Then we have module 3, which is not a webinar. So you see we have different formats. It will be just a series of materials like slides and videos on standards applied in environmental engineering and sustainable construction. Then we will have other 2 webinars on still one on digital topics, so how to achieve digitally sovereign and interoperable software solutions in June. And the 5th one will be the first one on more, let's say, green topics, so robust and effective standards and certification schemes for the bioeconomy at the end of June. However, we have more to confirm. We expect the series will run until the end of September, beginning of October 2026. And the program is still under construction because it's not only delivered by our consortium of partners and professors in Edu4Standards, but also by external contributors. So if in case you also are studying or working on these topics and would like to contribute your materials, or maybe ask us to co-organize a webinar with you, we're still open, okay, until October, to include your initiative or your knowledge, let's say, in this series of webinars. And the overall approach of the project is exactly this one, that we want to bring together people and exchange knowledge, and we are eager to cooperate with all of you. So this is it for the introduction. Just quick reminders on how we are managing logistically this event. The event is being recorded, and we will make the slides and the recording available on Edu4Standards website and YouTube channel within the next week. You have a Q&A box placed in the lower toolbar of Zoom, but you also have a chat. So you can ask and type, write your questions anytime you want. At the end of the webinar, we will have a dedicated session for Q&A, but if possible, we will also address your questions as they arrive, if they are, simple enough to be addressed quickly. So I now stop sharing my slides, and I welcome and leave the floor to Nizar to start his webinar.
Thank you, Maria. Thank you very much. I will share my screen. I hope it works well.
Yeah. Yes, it does.
Thank you. Yeah, thank you very much. So, thank you, Maria. I would like to welcome everyone joining this webinar. Thank you for being here. My name is Nizar Abdelkafi, and I'm from Politecnico Department of Management Engineering. And the title of my presentation today is Standards as Enablers of Digital and Green Transitions, a Multi-Level Perspective. Okay, so I start with a agenda of today's talk. So I will start with a short introduction on what is meant actually by a socio-technical transition, because this is really the foundation for everything that follows in my presentation. Then I will introduce the multi-level perspective. So this is a framework for transitions. And this will be also important for the next step, which is to discuss why standards matter and how standards can make systems work and scale. Then I will do some concrete examples. I will provide some concrete examples, in particular from digitalization and sustainability, which are actually the focus of this talk. And then at the end, I would have just a slide on looking ahead and how we may shape future systems. So, and I hope that at the end we will have a short discussion and Q&A. Good. Okay, I would like to start with this slide. And this slide shows that actually not all improvements are equal. Yeah, what does it mean exactly? So if we look at the bottom of the graph of the figure, okay, we see system optimization. So you can see also the two axes of the graph. We have time in years and also the factor improvement, for example, here in environmental efficiency. So at the very bottom, we have system optimization. So what does it mean, system optimization? It means just improving an existing system. An example is perhaps is making combustion engines and mobility in cars better, so they consume less energy. Okay. So and also, as you can see, the environmental benefit would be actually lowest in this case. Now we have the next type of improvement which we can achieve is the partial system redesign. It means that we are not changing the whole system, we are not rethinking the entire system, but what we are doing is that we are taking a part of the system and redesign it. An example for could be the integrated transport systems or multimodal transportation, for example, combining public transport, shared mobility, digital platforms. So we are not tackling the whole system, but just part of it, part of it. And then in this way, we can target or achieve a better improvement than in the case of the system optimization. When do we achieve actually highest level of improvement? is that when we have a system innovation. What does it mean, a system innovation? It means that actually we rethink the entire system. Okay, so we are discovering new ways of operating a system. Um, so the system will be working differently. An example could be electric vehicles powered by renewable energy. So here we are fundamentally changing the underlying technology, but also the energy system used for operating cars. And in this way, of course, we are achieving a high level of improvement as compared to system optimizations. So actually, we would like to get into system innovations. We would like to achieve a transition. So we go from a, an existing system to a system that is uh, more advantageous, perhaps from a sustainability point of view. And you can see here an example from, yeah, again, we take the example of a car. I will use this example more frequently in my talk. And you can see that this system is not only about technical change. So, and this is a key point, actually. We are not just replacing an existing technology with a new one. A car is actually not just a piece of technology, it is a part of a larger system. Now, what are the constituents of this larger system? We have the fuel infrastructure, right? So today it is almost, or it is mostly based on petrol stations, right? Then we have regulations, for example, the safety rules, the emissions, and standards. And then we have also the maintenance networks. We know exactly how to repair a broken car. But also there are elements that are less visible in the system. Um, for example, user lifestyles, right? So how people commute, how do we organize our daily life by using the car? Yeah, refueling, for example, is something we are used to maintain the car, also something that we are used to. We know the driving range of a fuel-based car, so we don't have that driving range anxiety, right? That it will stop in the middle of the road because we know exactly how long we can drive with a fuel based car when we have a full tank, right? Then we have cultural meanings. Yeah, the car has been the symbol for long times for freedom, also for status. And this actually, so the interactions of all these elements make make the transition actually very difficult, right? So they are interacting with each other, they are reinforcing each other. Um, yeah. So it's not only changing the technology, for example, it would be about changing the infrastructure, adapting regulations. And yeah, and therefore these kind of transitions, they will not happen very quickly. So it is not like when I'm updating an app and then it will function very quickly, but here it is about transitioning with the entire system. So more or less rewiring this system, breaking the connections existing and reconfiguring it again. And these kind of transitions, they will take 30 to 50 years. Okay. So this is yeah, very important to keep in mind. And still yeah, because it is so complex, transitions are complex. Many technologies, yeah, they simply fail to scale, and the question is why. And there are, yeah, a couple of reasons. So here I have an example of the reasons that could lead to the fact that some technologies fail and we do not achieve the transition that we are looking for. For example, fragmentation. Yeah, what does it mean, fragmentation? Fragmentation, um, yeah, if we take electric vehicle charging, yeah, for a long time we had different competing charging standards, right? So there is a fragmentation of the market. There is so it is unclear actually for users what standards will be used in the future, and also for investors, and for infrastructure providers. This is very related also to uncertainty. Which investor would invest in a technology that is still evolving? Because yeah, investments, they are sunk costs. What does it mean, sunk costs? It means we invest in them, we cannot reverse back the investment. And many investors or many companies investing in technologies that are still emerging, this can lead to the bankruptcy of the companies, or the survival of the company could be at risk. So in general, what investors would do because of this uncertainty, they will delay investment. Okay. Then we have the lack of coordination. We have seen before how many actors are actually involved in such transitions. Users, regulation, infrastructure providers, producers, and all of these actors have to be coordinated, right? So if one group moves ahead, but the others do not move, so there will be, at the end, no transformation. There will be no accommodation of the new technology. So what actually enables um, uh, large transformations? And here I would like really to refer to this model, which has been developed by Giels 2002, and there has been a lot of publications from Giels, who is a professor in Manchester, talking and researching transitions, how transitions are actually take place, and how they are um, concretizing in real life. So in order to understand transitions, so first of all, we start with a static multi-level perspective. It is called multi-level perspective because there are different levels in this model. The first, I would like to focus on the middle one, the one which is called actually socio-technical regime. Socio-technical regime is the system that we discussed before. Actually, technologies, infrastructures, regulations, and users, all of them connect together and use the technology. So in general, we do not talk only about technologies, right? So we are talking about a connection of many things. It is called a socio-technical regime. And change actually could happen in the socio-technical regime, but very important to understand that in the socio-technical regime, we have the key characteristic is stability, right? It's stable. We can have some changes, but they are marginal, incremental changes. So, and these changes, they aim, for example, to improve some efficiency. So it would be rather a system optimization than a system transformation. So the system stability is a key feature. And we say that the system is actually locked in. So we are locked in a certain socio-technical regime. Now, very interesting, we have the niches. The niches, they are early stage technologies. So let's say the electric vehicles, perhaps 20 years ago, they were. But by the way, the niches which are the novelties, they are called hopeful monstrosities. I repeat the word because it's really interesting. Hopeful monstrosities. They are monsters. The technologies at early stages. Why they are monsters? Because they have low performance. They are unreliable. They are very costly. And yeah, if you look also at the technologies in the past, let's say electric vehicles, which we have them even before we have the electrical cars before the combustion engine cars. And these electric vehicles, they were hopeful, they were monsters because they were, the driving range is very short. You cannot drive long time with them. So it was at the beginning of the century, right? And they were also not reliable. They may have acid leaks from the battery. And by the way, this is just an anecdote. I'm not sure that if it is true or not, but I found it on the internet that Clara Ford, the wife of Henry Ford, um, she was driving an electric vehicle because she found annoying all the noise that is produced by the combustion engine. Even though it is, yeah, as I told you, it is a monster. Actually, it is a hopeful monstrosity. And also, if you look at early computers at the very beginning, you had to put to fit the computer into a big room, and it consumes a lot of energy. Perhaps the calculators that we have now, they have much more power. So, but still, yeah, these niches they provide certain protection, right, to the new technologies, because if they would like to come into the regime and to the socio-technical regime that is established, yeah, they are too vulnerable. Um, they are hopeful, but they are still not that good. And yeah, this is with respect to the third level. This is the niches, and then we have the landscape. The landscape is about the external context. This is about what is happening outside. I would like to yeah, say something about the macro level landscape. Yeah, it is the external structure or context of our interactions of actors. Um, we can distinguish between two types of changes in the macro level landscape, and they are exogenous contexts, so exogenous changes that are coming from outside. We have slow changing trends, like, for example, demographics, climate change, um, yeah, geopolitics, digitalization also. So they are, let's say, putting pressure on the socio-technical regime, yeah, the regime to which we are used, yeah, slowly and in a progressive way. But we also have shocks. For example, shocks that could emerge in the landscape, and they have perhaps a disruptive effect on the system. They could be oil shocks, they could be recessions, they could be wars or pandemics like the COVID-19 pandemic. And these um, developments actually create a lot of pressure on our current socio-technical regime. So let's say our socio-technical regime at the moment, we are using certain unsustainable technologies. We know that they are unsustainable, but we are locked in. There are a lot of infrastructures out there, and still we feel the pressure of, yeah, sustainability, right? That we should do something for the climate change. Yeah, a good example is the fashion industry. Yeah, the fast fashion industry. So the regime is very, very established, and the users are also, I would say, many users, they are happy with the system. They would like to get fast fashion, but still we have that pressure coming from the outside. Yeah, claiming and asking for more and more sustainability and for decarbonization, right? And for less waste, etc. Okay, so this is the idea of the macro level, and still pressures coming from outside. They could be not strong enough, and therefore we can say that our system is locked in. And there are different types of lock-ins. There is economic lock-in. So existing systems are built on massive investments, right? Like oil refineries or gas pipelines, fueling stations that we use them every day, certain production facilities. These investments, they are worth billions. So people would not like to change them. Companies would like to change them. So there is an economic lock-in. We have also the social lock-in. Yeah, these are the cognitive routines, our lifestyles, the existing social capital, the relationships between people. And change is always very difficult. Why? Because change means rewiring also our mind. And believe me, this is also known in psychology, rewiring our mind. It means rewiring our neurons in the brain. This is painful. We would like to stay with the old system, right? And this is, yeah, our social lock-in. And there's also the political lock-in. Yeah. Incumbents, which are the existing companies, which are benefiting from the existing system, from the existing infrastructure, they are, yeah, they have big interest that the system stays as it is, that it does not change. So yeah, and these incumbents, these existing companies, they exert influence, of course. They have significant power. They can exert influence on regulations. on lobbying policymakers, resisting change in general. So when they feel this pressure, actually, what they do is that they try to make some incremental tweaks to change a bit the system, to improve it a bit, in order to say, yeah, our system functions very well. We don't need change. So you can see here that the system is sealed. So there is a concrete sealed system. The socio-technical regime is out there, is difficult to change. But the question is, when does this system change? And this is what the framework of Kiel's actually say, and this is very, very interesting, is and this is the dynamic multi-level perspective on transition. So by the way, Gies is one of the first researchers and scientists who thought about how transitions take place, right? And since he also founded this area of transition frameworks and theories, and since then the transition could be also understood as a discipline. Now, what this picture actually show us? So it's yeah, you should think of the socio-technical regime as the system in the middle as a stable one, a system that does not want to change, system that works very well, and yeah, a lot of people benefit from it, a lot of companies, etc., benefit from it, and they would like that it stay the same. And then all of a sudden, or it could be also over time, there are pressures coming from the external side. So from the outside, these pressures could be stronger and stronger and stronger until that socio-technical regime breaks. So there is a break here, a break in the socio-technical regime. And only then, when there are a break in the socio-technical regime, the niches that are bubbling up, let's say, below, they have the opportunity to enter in and to scale. We call this, yeah, when there is a broken socio-technical regime, that we get windows of opportunity, right? So there are windows of opportunities that are created in order for the niches to come in. I give you an example which is, yeah, very interesting. In 2011, there has been the problem, or there has been the natural catastrophe in Japan, and there has been the tsunami, and this tsunami led to the fact that there has been a lot of nuclear leaks, and nuclear plants had many issues, and many. So we have observed that we have seen that the German government, for example, has taken that very, very seriously. It was like a shock for the socio-technical regime and energy in Germany. A couple of days after that shock, the German government has decided to phase out nuclear plants in Germany. So this was like breaking more or less the socio-technical regime. And yeah, of course, Germany at that time, the energy vendor, so the use of renewable resources was already going on. But that shock, that Fukushima tsunami has led to a big shock to the system that the energy vendor in Germany has accelerated. So this is a concrete example how this dynamic multi-level transition framework explains how transitions work. Actually, we can have different paths for or different pathways how we can get the transitions. We can have technological substitutions. What does it mean? It means that a new mature technology replaces an old one. For example, digital cameras. Digital cameras have just replaced analog cameras, although, yeah, and at that time, the Kodak, which was the inventor of digital photography, could not benefit the new technology, and others could benefit from it. We can have a regime transformation. So here it is when existing actors adopt a new technology, or adapt and change. For example, We see, um, for example, automotive manufacturers that are adapting and adopting electric vehicles, right? They are shifting toward electric vehicles. We can have reconfigurations, and this is very, very interesting. So when technologies are initially used to solve a specific problem, let's say we use software for optimizing fuel injections in conventional engines, right? So it was one of the beginnings, like using software inside the car. But what we see now is that software is everywhere in the car. And these are digital technologies in the cars which have turned the cars to a complex system. We talk about, yeah, computers on wheels in the meantime, right? So these digital technologies that come step by step and devastate, let's say, the electric or the car in general, they are transforming the entire system. And finally, we can have a system of de-alignment and realignment. We can have, let's say, a big disruptive shock, and then all of a sudden, multiple innovations, they are competing in order to see one dominant design at the end win this competition. So there are possible pathways how to get into this. Now, I would like, I'm very interested in how these niches, these niche technologies can make it and enter into the socio-technical regime. So how we get from niches to, yeah, let's say a new climate technology, how we get that climate technology or that digitalization technology embedded into, into the regime. And this is a very important question. This is actually the essence of transition, sustainability transition, but also in digitalization transition. And it happens that standards, they help us a lot. They could shape and support the transition from niches to the socio-technical regime. What do standards do? Standards codify new knowledge. Actually, they translate innovation into shared specifications or specifications that many actors agree upon. Then we have standards. The standards establish shared rules for interoperability, right? So different components and actors, they can work together. And very important here is that the standards also reduce uncertainty for investors. Okay, we have already talked about this. So what standards do, and this is extremely relevant. Actually, standards, they stabilize emerging systems and represent a mechanism that can turn a hopeful monstrosity, this technology to the niches, into reliable and scalable solution. Good. In general, standards, they constitute a value-laden artifact. So imagine this. So you have a new technology. Let's say you have an AI technology. You have yeah, a sustainability technology, whatever. So what we would like to know as normal users, so the society that is using this technology, to which extent this technology is safe, to which extent it can protect me, to which extent I can use it without having any worries, right? So standards, they embody actually the specific choices about what is considered actually as safe, what is considered as acceptable, and what is also considered as a desirable. And in this way, actually standards, they emerge as recipes for reality, recipes that shape our reality, our systems, right? Um, let's try to think of this with an example. So, yeah, so we are all electricity consumers, right? So households in the past, they were used to get the electricity delivered in one-way direction. Okay. So there are plants, utility plants making or producing that energy, and that energy is used by households. But now we can have, with the renewable energies, with these new technologies, we can have an energy flow in both directions. But in order to have this energy flow in both directions, people should agree about this. Regulation also should allow this, should provide its permissions to this. And also standards should be out there to facilitate this. So this is really very important when we have new technologies. Standards and standardization processes can play an important role in stabilizing these emerging systems. But I would like here also to provide a caveat, right? Standards are also have been stabilizing for a certain period of time the old system, right? So here we should think of standards also as a double-edged sword. So they can reinforce existing systems, but also they are very important mechanisms through which new systems become stable and widely adopted. Okay, so now I would like to go deeper into how standards stabilize the socio-technical systems. And there are three pillars. I will try to explain them a bit here, and then I will give some examples for each of these pillars. Now, first is the technical coordination. So standards make disparate components work seamlessly together while creating ecosystems that promotes economies of scale and healthy competition. So this technical coordination is due to compatibility. So compatibility meaning that how we are making different components fit together, right? But also due to this technical coordination means also interoperability, meaning that components are talking together. An important other pillar is infrastructure alignment. Standards enable infrastructure alignment. So here, standards, they help align larger systems like infrastructures, markets, and services, right? So without this alignment, even well-functioning technology, an excellent technology, a very sophisticated technology will not be able to scale. So here it's very important that the standards go into play, that they are created in order to align all the parts of the infrastructure. And then, most importantly, standards provide also normative legitimacy. What does it mean, normative legitimacy? It means embedding values in ethics and driving trust in social aspects of new technologies. I would like to repeat it again here. It is not only about technologies, right? It is about socio-technical regimes. So a technology can enter the system and can scale only if people accept it. So the values of people are taken into account into the technology. And how do we take them into account? Of course, by using standards. Here, I would like also to make the difference between two types of standards, and we need them both, right? So there are the design-based standards, meaning that here standards that prescribe a clear solution, right? A clear technical procedure or technical solution. But also, there are the so-called performance-based standards. They are not prescribing a technical solution, but what they are doing is that they are showing some requirements, providing some performance we have to we have to achieve in order to be compliant with that standard. And we need both design-based standards, but also performance-based standards in order to achieve and support transitions. Now, the first pillar is about technical coordination. And a nice example is the Universal Serial Bus, which is the USB port. So I don't know, who are in our audience today, but perhaps in the 90s, you remember how it was when you look at the back of your computer panel, right? So you find, in the early 90s, I had many desktop computers, and when you look there, you have different ports, different devices, for keyboards, for printers, for mouse, for mice, for cameras, etc. So each device required connector and configuration. Now, imagine a startup that would like to innovate for a desktop computer with all of these types of ports, right? They will be spending about 80% of their time, yeah, trying to achieve the connectivity to different motherboards, let's say the IBM motherboard or the compact by motherboard or the Apple motherboard, and then dedicating only 20% for innovation. But then what happened is that in 1995, I think there had been many companies coming together, among them, I think Microsoft and IBM, in order to standardize and to develop the USB port. What do we have now? Let's take again the example of our startup spending 80% of their time in order to think about connections and actually not dedicating a lot of time to the real innovation. Now, these companies, they will not care about or care a lot about the connectors because the connectors, they are standardized. We use the USB system. They can dedicate more time for innovation. And when we have more innovations, we can better scale the ecosystem, right? So this is very important. So to scale the ecosystem, we need to focus on innovation and less, perhaps here, and especially in the computer industry, less on on connectors, right? Then the next example is about infrastructure alignment. What does it mean, infrastructure alignment? It means that we align the different parts that are used in order to operate the technology. Electric mobility is a very good example. So, electric vehicles, of course, faced in the past a classic chicken and egg problem. What is this chicken and egg problem? Without charging infrastructure, people will not buy electric vehicles. And without electric vehicles, companies and investors will not invest in the charging infrastructure. So here is very important that we invest in the that we have so-called internal infrastructure alignment, and this is achieved through standards. Yeah, an example here, which is very interesting, the ISO 15118, very interesting standard, and it is actually supporting this infrastructure alignment. It is called a plug and charge. Yeah, it could be, it supports the plug and charge. What does it mean? It means that when you go in order to charge your electric vehicle, you don't need to care about anything. Once you are plugging the electric car into the charging station, the charging station will connect automatically to the electric car will connect automatically to the charging station. So the electric car and the charging station will know each other. They will talk to each other. Then once the charging station identifies the car, it will automatically start delivering electricity. And after finishing the delivery of electricity, the billing or the payment will be done automatically. So this is infrastructure alignment in action, right? So it is not a fragmented infrastructure that we need to care about. Okay, the charging station, what is the plug? Then once we solve that, then now, how the standard, the charging station will communicate to the car, which software and which apps, then, okay, how should we pay? No, these problems are not there. So there is all of this infrastructure alignment together. Now, the last pillar is, and I think this is very important, especially with respect to AI, right? Yeah, it is called normative legitimacy. Yeah, and it is very related to AI governance. So here, and the key question is actually, how do we make society trust new technologies, especially complex ones like AI? So in general, do the users know what is happening inside that black box called AI? Do we know what are the things going on? So for example, when we are in areas like hiring, so when AI is providing a recommendation for hiring someone, or in finance, let's say when banks use AI in order to to provide a credit to somebody, or it is about healthcare. So healthcare that is yeah, using AI in order to manage people data and then perhaps to provide some recommendations. So here, yeah, people, although that we know how powerful the technology is, but we all have issues with that. And here comes standards into play. Standards can play a crucial role by translating abstract societal values like fairness, transparency, non-discrimination into requirements that can be implemented and evaluated. And here I would like to give you the example of ISO IEC 24027, which is actually not a standard, it is a technical report, but it is very, very important. What does it do? It helps actually identify the types of bias in the data, in the measurements, and in the algorithms, right? And it also provides methods and methods and procedures in order to evaluate and mitigate these biases across the AI lifecycle. So these standards are translating actually our societal values into specific requirements, right? So in order to trust more that that technology. So this is very important. Never thinking of technology as a standalone. A technology is always intertwined with society, and we have to consider values of society, and standards are the best way in order to include values of society into standards. So this is my last slide. To shape the green and digital future, we must write the standards. So what I have talked about is systemic transitions. They demand more than new technology, right? There are many, many actors that are involved. The multi-levelist perspective explains how transitions take place. We need actually these niches, these early stage technologies at the very bottom that are still low performance, but they are promising. They are the hopeful monstrosities. They are promising how to get them and improve them in the main socio-technical regime, right? And standards, they provide the invisible scaffold for socio-technical transitions. They coordinate technologies, they align infrastructures, and they embed societal values into technical systems. So if we are serious about shaping digital and green transitions, we cannot focus only on innovations. We also need to focus on standards because at the end, those who shape the standards, they also shape the future. Thank you very much for your attention. Good. So I would be happy to take some questions. And of course, I would like to, again, uh, attract your attention to the next webinar, which will be done by the 26th of May by my colleagues at UPM in Madrid about privacy, data protection, and standards and also European values. But before that, and yeah, I'm happy to get questions. Good.
Thank you, Nizar. We have a question actually for you in the Q&A. I'm not sure if you can uh, see it.
Perhaps I should interrupt
Oh, yes, you have to interrupt the.
the sharing.
Yes.
Yes.
Let's see if I can.
Um, okay, so it was from Mona.
Mhm.
Thank you, Mona, for the question. I will be reading the question and then, yeah, try to understand it and then answer. So great, greatly enjoyed this perspective. Thank you very much, Mona. As chair of IEEE 1955 on 6G empowering robotics, I'm exploring using Kiel's multi-level perspective to guide our standardization transition. Do you see this as a robust framework here? And how would you recommend applying it to achieve harmonized standardization across the niche, multidisciplinary, and landscape levels? So um, there are some transition frameworks, but I think this is yeah, one of the most important transition frameworks, the multi-level perspective by Giels. It's very useful. I'm using it also a lot in my work in order to interpret certain transitions and to see why some transitions have not taken place. It provides a nice framework. Of course, yeah, with respect to the transition to 6G, well, yeah, I think the framework shows, yeah, the three levels very clearly. We have to think about the macro level. Yeah, what do we have in the macro level? Do you have really pressures in order um, to shift to 6G? This is very relevant. Yeah, what about the regime that we are in now? What are let's say, what makes this regime really difficult to change? What about the user acceptance, the users' habits? What about the cultural aspects related to the technologies? And then what kind of yeah, niches are emerging? Because this is very important. What are kind of new applications, for example, in 6G that are emerging and that could, at some point in time, make it and get into the main regime. So I think, yeah, yeah, without really knowing exactly, yeah, the work in detail that you are doing, but I think it's, yeah, it could be useful at least to try it and to play with the framework, to which extent it could provide some recommendations or some new insights. I hope it could, yeah, answer the question. Mona. Thank you, Mona. Yeah, would be great if, yeah, you share some information about your work.
Okay, any other questions, curiosities, comments, suggestions? If not, we are approaching the end of the webinar. I will put in the chat the link to the next modules. So the next module will be also a webinar. So oh, okay. So Sabrina, thank you. My colleague already put the link to the second webinar. So we hope you enjoyed this introductory session, and we are looking forward to having you also in the next webinars of this series. Thank you very much, Nizar, for your presentation, and thank you all, and have a good continuation of the day and the week.
Thank you, Maria. Thank you all. Thank you very much.
Bye bye.
Bye bye.
Thank you, everyone.
Thank you.